Hi everyone, in this lecture we'll talk about insertion sort, just another sorting algorithm. So, and I know it's difficult to remember so many algorithms, so that's why I'm trying to relate these names with some examples. The idea of insertion sort, you can say, is inspired from playing of cards, like a card game. So for example, if you have certain cards in your hand and let's say they are already sorted, you have a card 5, you have a card 7, you have a card 8, and maybe now if I give you a card 6 and I want you to insert it in the right index, right place, so what you will do, you will say okay, let me start from the right and let's see, 8 is bigger, so maybe put it side, 7 is bigger, put it side, and maybe you create some space here between 5 and 7 and you insert this card at this particular position. So it basically becomes like 5, 6, 7 and 8. Okay, so this is exactly what we do in insertion sort, and if you remember this example, you will not never forget insertion sort in your life. So we need to see how this algorithm is going to work on an entire array. So the idea, as I discussed, is to insert a card or a number in its correct position in the sorted part. So what is this sorted part? What is this unsorted part? Let us look at through one example. Let's say we again have an array 5, 4, 1, 3 and 2. Let's say this is the array. So what we will do, we'll divide this array into two parts. Let's say this part, the first element is a sorted part and this part is a unsorted part. Okay, so an array of single element will always be sorted one. So now what we are going to do, we are going to pick this number, we are going to start from let's say I equal to 1, and we are going to see at which position we can place 4. Okay, so we have a card 5, so where do you want to place 4? So obviously 4 will come below before 5. So what we will do, we will uh, keep 4 in a temporary memory. We will say okay, I have kept out 4, 1, 3, 2 are lying as it is. We are not touching them as of now. So we popped out 4 and we said okay, go back and create a position for 4. Okay, so we can see 5 is greater than 4, so we will copy 5 here. Okay, and we'll try to go back. Now we can't go back any further, that means 4 will come here. Okay, so now we have two elements which are sorted and we have three elements which are not sorted. Again, we will pick one and we'll say okay, let us try to put one in the right position. So we see okay, what we do, we put one in a temporary memory. Let's say we put we copy one somewhere and we empty this position. Okay, and we have 4 and 5 here. Now we see 5 is greater than 1, so it will move one step ahead like this. We go back and check, can is 4 greater than 1? The answer is yes, so 4 also moves one step ahead, and finally we end up at this position. Okay, so we have moved 5, we have moved 4, and this position is empty, and here we are going to insert 1. Okay, so this is how we get three elements which are now sorted. Okay, next what we will do, we will say okay, we have 1, 4, 5, it is sorted. We have 3, 2, which is not sorted. We pick this element, we try to insert 3 in the right position. So what we do, we copy 3 in a temporary memory, we make this empty. We have a 5 here and 5 is greater than 3, so it moves one step ahead, so 5 comes here, and we have we come back one step, we have a 4 here. 4 is greater than 3, so 4 comes here, and 1 already is here. Okay, so we create an empty slot at this position. Okay, so we basically copy 4 to the next position, we copy 5 to the next position, and we have already copied 3 in a temporary memory. Now we see we are at 1. Is 1 bigger than 3? No, it's not. So we stop at this particular point. At this particular point, we the pointer is at this location. Okay, and we say okay, let's put 3 here, and this is how we insert 3 in its right position. So similar thing we will do for 2. So we have 1, 3, 4, 5. We copy 2 in a temporary memory and we keep on moving these elements one step ahead. So 5 goes here, 4 goes here, it becomes 4. 3 goes here, it becomes 3. 1 will not go here because 1 is not greater than 2, so we'll put a 2 here. So it will become 1, 2, 3, 4 and 5. Okay, so I hope the idea is clear. The idea is very simple, and in the next lecture it will become more clear once we discuss the implementation. So this is insertion sort. Let's see in the next lecture.